Hello, welcome to the video on multimedia information representation. I, Dr. Kumula M, Associate Professor from the Department of ECE, SJBIT, would like to explain about the multimedia information representation. The contents of this video are introduction to multimedia information, digitization principles, the text, image, audio, and video. Always it is very much essential for the conversion of an analog signal into digital form, which is very much required for an efficient transmission of the data on the communication channel. So the conversion of analog signal into digital will always require a signal encoder, the sampling, and a signal decoder. So the different digitization principles are the analog signals. The general properties relating to any type of time varying analog signal are possibly infinite number of signal frequencies. See, sinusoidal signals whose amplitude and phase vary continuously with time relative to each other. So, the bandwidth of the signal varies. The bandwidth of the transmission channel should always be equal to or greater than the bandwidth of the signal in a band limiting channel. So, here let us have a look about the signal properties of a analog signal which need to be disguised. The diagram explains or represents the time varying analog signal. Here we can see that as per the audio of the signal which is generated, the amplitude of the signal varies. And here second one is the sinusoidal frequency component which is in uniform in the transmission line, and a high frequency component which is generated by the low frequency oscillator during the modulation process and the demodulation process. So, and here we can also see the effect of a band limited signal transmission in the channel which creates different bandwidths. So next, the second stage of the conversion process is the encoder. So we need to design an encoder where it is a band limiting filter and an analog to digital converter to compromise a sample and hold and a quantizer. So a sample and hold circuit and a quantizer will remove the selected high frequency components from the source signal and is then fed to the sample and hold circuit, and the sample and hold circuit, the amplitude of the filter signal at regular time intervals will hold the sample amplitude constant between the different samples. So design of encoder. How do we design a encoder and how it can be used in the decoder is the question. So a quantizer circuit which converts each sample amplitude into a binary value which is known as a code word, and here in the encoder the signal to be sampled at a rate which is higher than the maximum rate of the change of the signal amplitude is 10, and here the number of different quantization levels will be used as large as possible. So when we are designing the encoder, we need to concentrate about the Nyquist sampling theorem, which states in order to obtain an accurate representation of a time varying analog signal, its amplitude must be sampled at a minimum rate that is equal to or greater than the twice of the highest sinusoidal frequency component which is present in the signal. So the encoder is designed keeping in mind the Nyquist rate and the distortion samples are obtained. So this is what we call it as aliased signal generation due to undersampling. Next, coming for the decoder design. The decoder is on the reproductive side of the original signal. I mean to say it will be at the receiver end. The output of the digital to analog converter is passed through a low pass filter which only passes those frequency components made up the original signal, filter signal. The audio or the video signal is encoded and decoded using the codec. So next, coming for the text formats in multimedia. Essentially, there are three types of text that are used to produce pages of documents. That is the unformatted text, the formatted text, and the hypertext. So now let us learn about this three text formats. The first one is unformatted text, which is also known as plain text, and enables pages to be created which comprise strings of fixed size characters from a limited character set. The second type is formatted text. The formatted text is also known as rich text and enables pages and complete documents to be created which comprise of strings of characters of different style, size, shape with tables, graphics and images inserted at appropriate points. Next is hypertext. The hypertext enables an integrated set of documents, each comprising formatted text which to be created, which have defined linkages between them. So the first one is the unformatted text. It creates a mosaic character relatively simple graphic images. So these are the ASIC text. And next, in formatted text, it produces most word processing packages, each with different headings and with tables, graphics, and pictures. Which in WISEWing, an acronym. What you see is what you get. So coming for hypertext, the format text which enables a related set of documents, normally referred to as pages, to be created which have defined link points referred as hyperlinks are called hypertext. So example of an electronic document written in hypertext is here we can see that we have the standard pages. Here it is shown of an example as per what we give is what we see. So next is all about images. There are also images. Always a multimedia signal includes images, but the images are displayed in the form of two-dimensional matrix of individual picture element, which are known as pixels or pels. So the image can be a graphical image. There's a range of software packages and program available for the creation of computer graphics, but the graphics provide easy to use tools to create graphics that are composed of all kinds of visual objects including lines, arcs, squares, rectangle, circle, oval, diamond, etc. So these are produced by drawings by the derived shape on the screen by means of combination of a cursor symbol on a screen. So the standardized forms of representation of a graphical images are GIF or GIF. So these are the graphic design principles where we can see that this is an example of screen format and we have a simple object example and we have the effect of change of position as per the diagram. Finally, we obtain a solid image. So how do we digitize the documents? As we all know, a digital input is nothing but representation of zeros or one. The data is represented in zeros or one. So when we are digitizing a document, A single binary digit is used to represent each pixel. A 0 for a white pixel and 1 for a black pixel. So this is the diagram which shows the decimal machine of principles. Here we can see that there's a paper being scanned. Next, the scanning is at, and there's a network where data is sent and printed in digital form. So distancing of pictures. In distillation of pictures, the color is a very important parameter. So we need to concentrate on color principles. A whole spectrum of colors known as color gamut can be produced by using different portions of red, green and blue. So the additive color mixing will produce a color image on the black surface, and the subtractive color mixing for producing a color image of white surfaces. So color division principles, additive coloring and subtractive coloring. So here we have the additive coloring and the subtractive coloring, which can be understood. So finally coming for the output of a computer or a television or a monitor principles, where we have the schematic, the raster scan principles and the pixel format of each line. So whenever we are trying to disguise the data, we concentrate on this important concepts and we also go with the principles. So for dissection of pictures, we use raster scan principle, progressive scan. Each complete set of horizontal scan is called a frame, and the number of pixels per bits per pixel is known as pixel depth and determines the range of the different colors. One more important parameter of design pictures is aspect ratio, where both the number of pixels per scanned life and the number of line line per frame is same. So the ratio of the screen with the screen height is much essential. We have the NTSC, NSCSIRE and SACM for these functions. Thank you.